Picture this. You're standing in a 6th century Byzantine church, and the walls around you are literally glowing with gold. Not painted gold, not gilded gold, but actual sheets of precious metal trapped between layers of glass, catching every flicker of candlelight like 1,000 tiny mirrors. This isn't some Hollywood special effect. This is real craftsmanship from Constantinople in 550 CE. And the techniques these artists used were so advanced they make modern tile work look like finger painting. But here's the thing that will blow your mind. These weren't just pretty decorations. These gold mosaics were engineering marvels that had to survive everything from earthquakes to centuries of candle smoke, and they're still shining today. The process of creating them involved secrets that were more closely guarded than state treasures, techniques so precise that one wrong move could ruin months of work. You might think slapping some gold leaf on a wall sounds simple enough. Wrong. These Byzantine masters had to solve problems that would make modern engineers scratch their heads. How do you keep gold from tarnishing when it's exposed to lime plaster? How do you cut glass without modern tools? And how do you make thousands of tiny pieces work together to create images so lifelike they seem to breathe? The answers to these questions reveal a world where art and science collided in ways that would make your chemistry teacher weep with joy. These craftsmen were basically running medieval laboratories, mixing materials, and developing techniques that wouldn't be fully understood until centuries later. They were the original mad scientists, except instead of creating monsters, they were creating masterpieces that would outlast empires. If you're finding this as fascinating as I am, make sure to hit that subscribe button and give this video a like, and definitely drop a comment about what surprised you most. Because trust me, we're just getting started, and the techniques these artists used get more mind-blowing as we dig deeper into their world. The story begins in the glass houses of Constantinople, where the real magic happened long before any artist ever touched a church wall. These weren't your neighborhood craft shops. We're talking about industrial operations that could have given modern factories a run for their money. The master glass makers had to create colored glass slabs that would hold their color for centuries, and they did it using techniques that sound more like alchemy than art. The process started with something called fritting, basically cooking sand, lime, and various metal oxides in furnaces that reached temperatures hot enough to melt copper. Different metals created different colors. Cobalt for deep blues that could rival the Mediterranean sky. Copper for greens so rich they looked like emeralds. And iron for reds that glowed like fresh blood. But getting these colors consistent was trickier than herding cats in a thunderstorm. Here's where it gets really interesting. The glassmakers didn't just dump everything into a pot and hope for the best. They had to understand chemistry in ways that wouldn't be formally documented for another 1,000 years. Too much metal oxide, and your glass would be opaque as mud. Too little, and you'd end up with something that looked like dirty water. The sweet spot required knowledge passed down through generations of craftsmen who probably couldn't even read, but could tell you the exact shade of flame needed for perfect cobalt blue. Once they had their colored glass slabs, some as thick as your thumb, came the delicate art of cutting them into tesserae. This is where things got seriously technical. The tools were deceptively simple. A hammer and something called a hardie, which was basically a sharp chisel fixed to a block. Sounds easy, right? Try cutting thousands of tiny, perfectly shaped pieces from brittle glass using nothing but medieval tools, and you'll quickly discover why these craftsmen were paid better than most nobles. The technique required the precision of a surgeon and the patience of a saint. Each strike of the hammer had to be exactly right. Too hard, and you'd shatter the whole piece into unusable fragments. Too soft, and you'd get jagged edges that wouldn't fit properly. The master cutters could produce tesserae so uniform they looked machine-made, which is impressive considering machines wouldn't be invented for another 1,000 years. But the real showstopper was creating the gold tesserae. This process was so complex and valuable that the techniques were kept as secret as nuclear launch codes. First, Craftsmen would take sheets of gold leaf, we're talking about metal so thin it would blow away in a gentle breeze, and carefully sandwich them between two layers of clear glass. This sounds simple until you realize that one speck of dust, one air bubble, or one moment of carelessness would ruin the entire piece. The layered gold glass sandwich then had to be refused in the furnace at exactly the right temperature. Too hot, and the gold would burn off or create ugly discoloration. Too cool, and the layers wouldn't bond properly, leaving you with expensive trash. The process required such precise temperature control that master craftsmen could judge the heat by the color of the flames and the sound the furnace made. They were basically human thermometers with an accuracy that would impress modern scientists. What made this technique truly brilliant was how it solved a problem that had plagued goldsmiths for centuries: tarnishing. Gold itself doesn't tarnish, but it can react with other materials, especially lime plaster. By sealing the gold between layers of glass, these craftsmen created a barrier that would protect the precious metal from everything the environment could throw at it. It was like creating a time capsule for each tiny piece of gold, ensuring it would shine just as brightly centuries later. The numbers behind this operation were staggering. A typical church mosaic might require over 1 million individual tesserae, and each one had to be cut by hand. The gold pieces alone could represent more precious metal than most kingdoms had in their treasuries. Some estimates suggest that the Hagia Sophia used enough gold in its mosaics to fund a small army for several years, but creating the tesserae was only half the battle. Getting them from the workshop to the church wall required a logistics operation that would make modern shipping companies nervous. These weren't mass-produced tiles that could be thrown in a box and shipped anywhere. Each tessera was a handcrafted piece of art that had to be transported carefully, sorted by color and size, and kept organized for the artists who would eventually place them. The workshops developed elaborate systems for categorizing their tesserae. Different shades of blue might be numbered from 1 to 20, with master craftsmen able to distinguish between variations so subtle that most people couldn't tell them apart. Gold pieces were graded not just by quality, but by the angle at which they would best catch light. Some pieces were specifically designed for areas that would receive direct sunlight, while others were crafted for shadowy corners where they needed to glow with their own internal light. Transportation was its own nightmare. Remember, this was an era before bubble wrap or shock-absorbing containers. Precious tesserae had to be moved through the streets of Constantinople in wooden crates, probably cushioned with straw or cloth. One accident, one overturned cart, and months of work could be reduced to expensive gravel. The workshops likely employed guards and used multiple routes to ensure their valuable cargo reached its destination intact. What's really impressive is how these craftsmen managed quality control without modern measuring tools. They developed techniques for ensuring consistency that relied on the human eye and hand rather than mechanical precision. Master artisans could spot a defective tessera from across a workshop, identifying problems that might not become apparent until the piece was actually installed on the wall. The economic impact of this industry was enormous. Entire neighborhoods in Constantinople were dedicated to mosaic production, with families passing down techniques through generations. The demand for quality tesserae was so high that successful workshop owners became wealthy enough to commission their own mosaics, creating a cycle where the craftsmen who made the art could afford to buy it. But all this preparation and craftsmanship meant nothing if the installation wasn't perfect. That's where the real artistry began, taking these thousands of individual pieces and transforming them into images that would make angels weep. The masons and setters who worked on church walls weren't just laborers, they were artists who understood light, shadow, and human perception in ways that wouldn't be formally studied until the Renaissance. The installation process began long before the first tessera touched the wall. Site preparation was crucial, and it started with creating a surface that would last for centuries. This wasn't your typical drywall and paint job. These walls had to support the weight of thousands of glass and gold pieces, while dealing with the expansion and contraction that comes with changing temperatures and humidity. The masons started with what they called the arriccio, a rough coat of lime mortar that went directly onto the stone wall. This wasn't just slapping on some cement and calling it a day. The mixture had to be perfect. Too much lime and it would crack as it dried. Too little and it wouldn't bond properly to the stone. These craftsmen were mixing chemistry decades before anyone knew what chemistry was, creating formulas through trial and error that modern scientists would spend years trying to replicate. But here's where things get really wild. The lime they used wasn't just any lime. It was aged lime that had been sitting in pits for months, sometimes years. Think of it like fine wine, except instead of getting you drunk, it created a plaster so durable it could outlast civilizations. The aging process broke down the lime particles into smaller and smaller pieces, creating a smoother, stronger material that bonded to stone like it was meant to be there. The real genius was in the timing. Fresh lime plaster has a working window of just a few hours before it starts to harden. Miss that window, and you'd have to scrape everything off and start over. So the masons developed a system where they only mixed and applied as much plaster as the mosaic setters could work with in a single day. It was like running a restaurant kitchen where every dish had to be perfect and nothing could be reheated. The surface preparation required mathematical precision that would impress modern architects. The wall had to be perfectly level and smooth, but not too smooth. The tesserae needed something to grip onto. Master masons used tools that were basically medieval spirit levels, checking and rechecking every surface until it met their exacting standards. One high spot or a low spot could throw off the entire design, making figures look distorted or breaking the illusion of three-dimensional depth. Once the rough coat was perfect, the real artistry began with the intonaco, the final setting bed where the tesserae would actually be placed. This layer was only applied in small sections, maybe 3 feet square at most, because once it started to set, there was no going back. The plaster mixture for this final coat was even more precise than the rough coat, with additives that modern chemists are still trying to understand. Some workshops added crushed marble dust to their setting bed, creating a surface that was almost glass smooth. Others mixed in powdered brick, which gave the plaster a slight tooth that helped grip the tesserae. The most secretive craftsmen added mysterious ingredients that they claimed improved the bond, everything from egg whites to wine, creating plaster recipes that sounded more like cooking instructions than construction materials. The transfer of the design from drawing to wall was an art form in itself. Master artists would create full-size cartoons, detailed drawings on paper or parchment that showed exactly where each colour and shape should go. But transferring these designs to wet plaster required techniques that were part art, part engineering, and part magic trick. The most common method involved perforating the cartoon with tiny holes along all the major lines, then dusting charcoal powder through the holes onto the wet plaster. This created a connect the dots pattern that the setters could follow. But the real skill came in interpreting these guidelines, because a successful mosaic required much more than just filling in the lines. The setters had to understand how light would hit each surface, how colours would interact with their neighbours, and how the viewing angle would affect the final appearance. What made this even more challenging was that Byzantine mosaics weren't meant to be viewed straight on like modern wall art. These were designed for churches where people would be looking up at angles, where candlelight would flicker across surfaces, and where the gold would need to catch and reflect light from multiple sources. The setters had to think like lighting designers, positioning each tessera not just for its colour, but for how it would interact with the illumination. The actual placement of tesserae was where craftsmanship met psychology. Each piece was pressed into the plaster at a slight angle, not random angles, but carefully calculated tilts that would catch and reflect light in specific ways. The technique was called the andamento, and it was like creating a three-dimensional painting where every brushstroke was a tiny mirror. For faces and detailed work, the setters used tesserae so small they were barely bigger than fingernails. Each piece had to be cut to fit its exact location, creating smooth curves and subtle color transitions that would fool the eye from a distance. The skill required was extraordinary. Imagine trying to create a photorealistic portrait using thousands of tiny colored squares, each one requiring individual attention and placement. But the backgrounds and larger areas used bigger tesserae, sometimes as large as postage stamps. This wasn't just for efficiency. The different sizes created visual rhythms that drew the eye through the composition. Master setters understood that the human brain processes patterns and textures in specific ways, and they used tessera size like a modern graphic designer might use typography. The color placement followed rules that were part artistic tradition and part optical science. Deep blues and greens were used to frame halos, creating contrast that made the gold centers appear to glow with their own light. The sequence of installation was crucial too. Faces went in first, then clothing and details, and finally the gold backgrounds that would tie everything together. The gold background installation was perhaps the most critical part of the entire process. These weren't just randomly placed golden tiles. Each piece was positioned to catch the specific lighting conditions of its location in the church. Tesserae near windows were angled to reflect natural light back toward the congregation. Pieces in darker areas were tilted to catch and amplify candlelight. The setters had to think like architects, understanding how light moved through the building at different times of day and seasons of the year. The joints between tesserae were kept incredibly tight, sometimes less than a millimeter apart. Any excess plaster that squeezed up between the pieces had to be cleaned away immediately before the plaster bed began to stiffen. This required tools so fine they were more like surgical instruments than construction equipment. Tiny scrapers and brushes that could clean joints without disturbing the carefully positioned tesserae. Quality control during installation was ruthless. Master artisans would inspect the work constantly, and any tessera that wasn't perfectly positioned would be removed and reset. The standards were so high that apprentices might spend years just learning to place background tiles properly before they were trusted with more detailed work. A single misplaced piece could ruin the optical illusion of an entire section. The working conditions were brutal by modern standards. Setters worked on scaffolding that would make today's safety inspectors faint, often in cramped positions for hours at a time. The lime plaster was caustic enough to burn skin, so craftsmen developed techniques for protecting their hands while maintaining the sensitivity needed for precise work. Many experienced setters had permanent stains on their fingers from years of handling lime and metal oxides. But perhaps the most impressive aspect was the collaborative nature of the work. A major church mosaic might involve dozens of craftsmen working simultaneously, each responsible for specific areas, but all contributing to a unified whole. The coordination required was extraordinary, like conducting an orchestra where every musician was also a composer, creating individual parts that had to harmonize perfectly with everyone else's work. The final touches were where the true masters separated themselves from the merely skilled. After weeks or months of painstaking tessera placement, the mosaic wasn't done. It was just ready for the details that would bring it to life. Inscriptions had to be added, and these weren't simple labels slapped on as an afterthought. Byzantine inscriptions were art forms themselves, with letter forms that had to match the style and scale of the surrounding imagery. Creating text in mosaic was like trying to write with a handful of colored pebbles. Each letter required dozens of tiny tesserae, cut to specific shapes that would create readable forms when viewed from the church floor. The letter cutters were specialists within specialists, craftsmen who understood typography centuries before anyone invented the printing press. They had to know how thick each stroke should be, how much space to leave between letters, and how to make text readable from distances that might stretch across an entire nave. But here's what made it really tricky. The text had to be readable from multiple angles and lighting conditions. An inscription that looked perfect in morning light might be completely illegible by candlelight. The setters had to angle each letter tesserae to catch available light while maintaining the proper proportions. It was like creating a three-dimensional font where every character was also a tiny mirror. Border bands presented their own unique challenges. These decorative strips that framed major scenes weren't just pretty ribbons. They were optical devices that helped define spaces and guide the viewer's eye through the composition. The patterns had to be mathematically precise, with repeating elements that lined up perfectly across spans that might stretch for dozens of feet. The geometry involved was mind-boggling. Master designers had to calculate how many pattern repeats would fit across a given distance, then adjust the size of individual elements so everything came out even. There was no room for error. A border that didn't line up properly would draw attention away from the main imagery and ruin the entire effect. Some craftsmen developed their own systems of proportion and measurement, creating mathematical relationships that wouldn't be formally studied until the development of advanced geometry. Color transitions in borders required an understanding of optics that bordered on scientific. The human eye perceives colors differently depending on what surrounds them, and border designers exploited this to create effects that seem impossible. A blue that looked dark when surrounded by gold could appear bright and vibrant when placed next to deep red. Master craftsmen created color wheels in their heads, understanding relationships that wouldn't be formally documented for centuries. The scaffold removal was a moment of truth that would make your heart stop. After months of work, seeing the mosaic from ground level for the first time was either a moment of triumph or a devastating realization that something had gone wrong. There was no Photoshop, no second chances. What you saw was what you got. The inspection process was thorough and brutal, with master artisans examining every square foot for problems that might not be fixable. Viewing angles revealed issues that weren't apparent during installation. A section that looked perfect from the scaffolding might appear distorted from the church floor. Colors that seemed to match perfectly up close might clash horribly when seen from a distance. The optical science involved was incredibly advanced. These craftsmen understood perspective, color theory, and human perception in ways that wouldn't be formally studied until the Renaissance. The numbers behind a completed mosaic were staggering in their precision. A typical Byzantine church mosaic contained between 800 and 300 tesserae per square metre. That's roughly the same density as a modern high-resolution photograph, except each pixel was individually cut and placed by hand. The gold content alone represented a fortune that could feed a small town for months. Daily work quotas were strictly controlled by the properties of lime plaster. A skilled crew could typically complete about 2 square meters of detailed figural work in a single day before the plaster bed began to harden. This meant that major church decorations might take years to complete, with work proceeding section by careful section. The planning required was extraordinary, like running a construction project where you could only pour concrete in batches the size of dining room tables. The layer structure of a completed mosaic was an engineering marvel that modern builders still study. Starting from the original stone wall, you had the rough oricio coat, then the smooth intonaco setting bed, and finally the tesserae themselves. Each layer had to be perfectly compatible with the others, expanding and contracting together through centuries of temperature changes without cracking or delaminating. But perhaps the most impressive aspect was the maintenance system these craftsmen built into their work. They understood that their mosaics would need care for centuries, so they designed them to be maintainable. Individual tesserae could be removed and replaced without damaging surrounding areas. Sections could be rebedded if the underlying plaster failed. The whole system was engineered for longevity in ways that put modern planned obsolescence to shame. Soot cleaning became a regular ritual in Byzantine churches. Centuries of candle smoke would gradually dim the gold surfaces, But the craftsmen had anticipated this. They developed cleaning techniques that could remove accumulated grime without damaging the delicate tesserae surfaces. Special brushes made from soft animal hair could clean individual pieces, while mild acid solutions could dissolve stubborn deposits without attacking the glass or gold. Crack patching required surgical precision. When the building settled or earthquakes caused minor damage, repair craftsmen had to match not just the colors, but the exact angles of the original installation. They maintained stocks of tesserae in every shade used in the original work, sometimes storing replacement materials for decades before they were needed. The repair techniques were so sophisticated that modern conservators often can't tell original work from later fixes. Rebedding was the nuclear option of mosaic maintenance. When underlying plaster failed, entire sections might need to be removed, the wall re-prepared, and the tesserae reset. Master craftsmen developed techniques for salvaging original tesserae from failed sections, cleaning off old plaster, and reusing pieces that might be centuries old. The skill required was extraordinary, like performing surgery on a patient made of thousands of tiny mirrors. The longevity of these mosaics is a testament to the sophistication of 6th century craftsmanship. Many Byzantine mosaics have survived for over 1,400 years, still glowing with the same brilliance their creators intended. They've survived earthquakes, wars, changes in religious fashion, and centuries of environmental stress. The Hagia Sophia's mosaics were even plastered over during the Ottoman period, then uncovered centuries later in nearly perfect condition. Temperature cycling that would destroy in modern installations barely affected these ancient works. The lime-based plasters could expand and contract with seasonal changes without cracking. The glass tesserae were essentially indestructible, immune to everything except direct mechanical damage. Even the gold remained bright and untarnished, protected by its glass sandwich from centuries of atmospheric pollution. Humidity changes that would warp modern materials had minimal effect on Byzantine mosaics. The hygroscopic properties of lime plaster meant it could absorb and release moisture gradually, buffering the tesserae from rapid changes. The craftsmen had created a system that was naturally climate-controlled, centuries before anyone understood the science behind it. The maintenance cycle they established became a tradition that lasted for centuries. Cleaning schedules were built into religious calendars, with specific feast days designated for mosaic care. Repair craftsmen were trained in techniques that were passed down through generations, maintaining skills that might be needed only once in a lifetime, but were too important to lose. What's truly remarkable is how these maintenance systems survived the fall of the Byzantine Empire. Even under Ottoman rule, craftsmen continued to care for Christian mosaics, preserving techniques and knowledge that bridged religious and cultural divides. The mosaics themselves became ambassadors for their creators, speaking across centuries about the skill and dedication of craftsmen whose names we'll never know. The economics of maintenance were built into the original construction contracts. Churches set aside funds specifically for mosaic care, understanding that these installations were investments that would appreciate over centuries. The cost of maintenance was tiny compared to the original investment, making these mosaics some of the most cost-effective art installations in history. Modern conservation scientists study Byzantine maintenance techniques to understand how to care for contemporary artworks. The preventive conservation methods developed in 6th century Constantinople are still considered best practices for protecting cultural heritage. These ancient craftsmen understood concepts like microclimate control, chemical compatibility, and structural monitoring that modern museums spend millions trying to implement. The knowledge transfer systems they established were remarkably sophisticated. Master craftsmen maintained detailed records of materials, techniques, and maintenance schedules. Apprenticeship programs ensured that critical knowledge survived even when individual masters died. Guild structures protected trade secrets while ensuring they weren't lost entirely. The whole system was designed for continuity across centuries, not just individual lifetimes. The documentation systems these craftsmen developed would make modern project managers jealous. They maintained what we'd now call quality control databases, tracking which workshops produced which batches of tesserae, which craftsmen worked on specific sections, and even which lime pits provided plaster for different areas. This wasn't just bureaucratic paperwork. It was essential information for future repairs. Here's something that'll blow your mind. They actually created color-coded maps of their installations. Different workshops had their own marking systems, tiny symbols carved into plaster or hidden behind tesserae that identified the source of materials and the date of installation. It was like having a medieval barcode system, except instead of tracking inventory, they were tracking artwork that would outlast empires. The training programs for mosaic maintenance were as rigorous as medical school. Apprentices spent years learning to identify different types of damage, understand the chemistry of cleaning solutions, and master the delicate touch needed for tesserae replacement. They had to memorize the exact shade variations used in every major church, because replacing a single piece with the wrong color could ruin an entire composition. But here's where the real genius shows. These craftsmen understood something about human psychology that modern advertisers spend billions trying to figure out. They knew that people don't just see mosaics, they experience them. The way light moves across gold surfaces, how colors shift as you walk through a space, the way details emerge and disappear depending on your viewing angle. They were creating immersive environments centuries before anyone invented virtual reality. The optical tricks they employed were so sophisticated that modern lighting designers study Byzantine churches to understand how to manipulate perception. They used tesserae angles, like pixels in a display, creating surfaces that could appear flat or curved, bright or shadowed, depending on the light source. Some sections were designed to look completely different in morning light versus evening candlelight, creating mosaics that literally transformed throughout the day. The mathematical precision behind these optical effects required knowledge that wouldn't be formally documented until the development of advanced optics. Master craftsmen could calculate reflection angles in their heads, understanding how a tesserae tilted at 15 degrees would interact with light coming from a window 30 feet away. They were basically running physics simulations using nothing but experience and intuition. Temperature considerations went far beyond basic thermal expansion. These craftsmen understood that different materials heated and cooled at different rates, and they used this knowledge to create installations that were essentially self-adjusting. Gold expanded differently than glass, which expanded differently than lime plaster. By controlling these differences, they created mosaics that actually got tighter and more stable over time. The seasonal behavior of their installations was planned with astronomical precision. They knew exactly how the sun would move through their churches throughout the year, and they designed their mosaics accordingly. Certain scenes were meant to be illuminated only during specific religious seasons, creating a calendar effect where the building itself told time through light and shadow. Seismic engineering was another hidden aspect of their craft. Constantinople sat in an earthquake zone, and these craftsmen had to create installations that could survive ground movement that would destroy modern buildings. They developed techniques for creating flexible joints between sections, allowing large mosaics to bend without breaking. The lime plaster beds could absorb tremendous stress, distributing forces across entire walls rather than concentrating them at failure points. The acoustic properties of mosaic surfaces were carefully considered too. Sound behaves differently when it hits angled tesserae surfaces versus flat-painted walls. Master craftsmen understood how their installations would affect the church's acoustics, designing surfaces that would enhance the singing of choirs or the speaking of priests. They were creating architectural instruments tuned for human voices. Quality control during the Byzantine period was enforced through systems that would make modern ISO standards look casual. Every stage of production had multiple inspection points, with different craftsmen responsible for checking different aspects of the work. Color consistency was verified by masters who had spent decades training their eyes to detect minute variations. Surface preparation was inspected with tools that could detect irregularities smaller than a grain of sand. The rejection rates for substandard work were brutal. Historical records suggest that up to 30% of tesserae might be rejected during quality control, sent back to workshops for recutting or complete remaking. This wasn't waste. It was an investment in longevity. The craftsmen understood that a single poorly made piece could eventually cause the failure of an entire section. Material sourcing reached across the known world. The best gold came from African mines, transported thousands of miles through trade networks that spanned continents. Cobalt for the finest blues was imported from Persia, while the clearest glass came from workshops in Syria. Creating a single major mosaic required coordinating supply chains that would challenge modern logistics companies. So there you have it, the incredible story of Byzantine gold mosaics, where medieval craftsmen created technology so advanced it makes your smartphone look like a cave painting. These weren't just artists throwing pretty stones at walls. They were engineers, chemists, and mathematicians rolled into one, solving problems with nothing but hammers, lime, and enough determination to make a mountain climber jealous. The next time you see a modern mosaic, remember that 15 centuries ago, craftsmen in Constantinople were already doing it better, creating masterpieces that are still glowing today while our contemporary art fades faster than yesterday's headlines.